Alright, so today we're doing volumes of integration using the disk and washer method. This first problem consists of 4 different lines. We need to find the area enclosed by all 4 lines and then rotate it about the x-axis. So our first step is going to be to graph this. So we'll draw coordinate axis. We'll graph y equals 1 over x, which looks like that in the first quadrant. Then we'll graph x equals 1, x equals 2, and then y equals 0 is the x-axis there. So this little area is what we're going to be rotating, and we're also rotating about the x-axis, which is here, so we're going to be rotating it down this way. Okay, so now if we blow up this picture to make it larger, over here we've got something that looks like this. Here's the x-axis, and we've got line here, line here. So this is x equals 2, x equals 1 is this vertical line, and then y equals 1 over x. So now we're going to rotate it about our x-axis, so we're going to just draw the same lines down here and draw something of a mirror image. So now what this gives us is we're going to be making basically circular discs that will be rotating around this way. So what we need to do is, if we draw one of these circular discs, I'll go over here, draw one of these circular discs. Now we're going to rotate from here down to here along these lines. So it's going to look something like this. Now if we remember our formula for the disk method, in this case we've got a thin slice running up and down here, and then we rotate it vertically around the x-axis. So what we have now with this disk, it looks something like that, is we've got volume for a disk is going to be pi r squared times height. Alright, so in this case, if we go back to this first picture here, this little slice that we cut, this little distance represents the height, and that is a small change in the x direction because it's a thin slice that goes horizontally. So now our height is going to be called x. Our radius of our disk over here, the radius goes from the axis up to the graph. Okay, and this line we know is y equals 1 over x. So the radius is just going to be 1 over x minus 0. And now we also have pi, which still remains pi. And now what we do is we have here our height is actually, we're going to call it dx because it's a small differential change in the x direction. And now we're free to integrate. So the fact that we have dx in our integral over here means that we will be integrating from one x value to another. And if we look here, this area is closed off by x values of 1 and 2. So that means we're going to integrate from 1 to 2 of pi, which is a constant so we can pull it outside of integration, times r squared, which is 1 over x squared, and then just times our height, which is dx. So now we have, if we write that again, we have pi integral from 1 to 2 of 1 over x squared is just 1 over x squared times dx, which we can also write as pi integral from 1 to 2 of x to the negative 2 dx. And now we are free to integrate it, And if we integrate power rule, we just increase the power by 1 and then divide by that new number. So this will become pi times x to the -1 over -1, now evaluated from 2 to 1. This -1 we can pull out to just be in front of the pi. So we have negative pi times x to the -1 evaluated from 2 to 1, which now if we just plug 2 in there, we have negative pi times 1/2 minus negative pi times 1. Now if we distribute, this is negative pi over 2 plus pi, or finally we get a result of pi over 2. So that's how we do that first problem.